So far we have seen body plot and gain margin, phase margin. And then we have seen how to adjust K by using body plot. Now we are going to see polar plot and Nyquist plot. To understand Nyquist stability criterion, first of all, we must know what is mapping. What is mapping? Mapping means, suppose I am having S-plane. This is S-plane, am I correct? Since its axis is omega, x-axis is omega, y-axis is, x-axis is sigma, y-axis is j omega. Therefore, it is the imaginary plane, complex plane, that is S-plane. Complex plane is called S-plane. In that S-plane, you are taking one point, say S1. Take S1 and substitute in Q of S. Q of S equal to a transfer function G of S, that is 1 by tau S plus 1. That S1 point is substituted here. What is that point? A complex point. Am I correct or not? That complex point, let it be minus 2 plus J3. S1 is minus 2 plus J3. Substitute here minus 2 plus J3. Final number again complex number. Am I correct or not? If you substitute a complex number, again you will get a complex number. Plot it on a complex plane, another complex plane. This is another complex plane. Another complex plane. This complex plane is called G of S plane. Why? Because I substituted this S plane point on G of S and I got one complex number that is plotted here in the complex plane. That's why this plane is not S plane. This plane is called the G plane. I am taking Q of S. Q of S equal to 1 by Ts plus 1 or 1 by 5s plus 1. In that, what is the taken point? Minus 5 multiplied by minus 2 plus J3 plus 1. If you simplify this, again you will get a complex number. Again you will get a complex number. To convert this into complex number, you will multiply the numerator denominator by complex conjugate so that the denominator becomes a real number and the numerator becomes complex number. That and all you know. So anyhow, what we know that this is a complex number. That complex number is this. This complex number is this Q1. S1 is substituted in Q. You got a complex number Q1. Like that, I can take many points. S1, S2, S3, S4, S5, S6. Like that, I am taking many points and substituted in Q of S. I will get Q1, Q2, Q3, Q4 like that. I plotted here. I plotted in another plane called the Q plane. Why it is called the Q plane? Because the S plane point is substituted in the function Q and I got complex numbers. That's why this plane is called Q plane. Q plane. If the S plane points are substituted on a G plane, transfer function G, then this plane is called G plane. Suppose I am substituted all these points, S plane points, set of S plane points are substituted on G of S, H of S, then this plane is called GH plane. GH plane, that is called mapping. That is called mapping. I mapped this S1 in Q plane as Q1. Suppose I am taking one contour. Contour means closed path. Mathematics, contour means closed path. I am taking a contour C. I am taking many points on the contour, S1, S2, S3, S4, etc. I am doing mapping on Q. I am doing mapping on Q. It means what? Hereafter, I won't say substitute those points on Q and find those values. I won't say. Simply, I say you are doing mapping of that contour. It means taking many points on the contour, substituted in Q, and it is plotted on Q plane. So now we are having two planes. One is S plane, another one is Q plane. In the S plane, I am having a contour. I am having a contour C. I am selecting many points on the contour that is substituted on Q of S. I got many complex number. The first point minus 2 plus J3 is substituted. You got 1 by J3 or minus J.33. That point is plotted here. That point is plotted here. Like that, I selected many points and substituted. I got a contour here. I got a contour here. Suppose I'm having a pole of that Q of S inside that contour. I'm having a contour C. This is the contour in S plane. This is the contour in S plane. The contour is selected such a way that the pole is inside that contour. The pole is inside that contour. I have selected the contours such a way that the pole is inside the contour. If I do the mapping, how to do mapping? Select many points on this contour and substituted in this G of S, GH of S, GH of S. You got many points. GH1, GH2, GH3, GH4, like that. I plotted all these points. You got this mapping. This is the mapping. Mapping of C contour on GH plane. Mapping of C on GH plane. You notice that this mapping is encircle the circle in the anti-clockwise direction one time. So if the pole is inside that contour, that is mathematics. That is mathematics. So if a pole is inside the contour means, if you do the mapping, it will encircle the origin in the anti-clockwise direction. How I am telling the direction? If you select the S1, S2, S3 in the clockwise direction, here Q1, Q2, Q3 will move like this, like that in the anti-clockwise direction. Therefore, if the contour encloses the pole in the clockwise direction, then this mapping will encircle the origin in the anti-clockwise direction once. Suppose I am having two poles inside. I am having two poles inside the contour. If I do the mapping, it will encircle the origin twice. I can say like this. It encircle the origin twice. It encircle the origin twice. It encircle the origin twice if two poles are inside. That is mathematics. The in the S plane, this is S plane. This is S plane. This is Q plane. You are doing mapping, selecting S1, S1, S2, S3. You are selecting many points on the contour and substituted in Q of S. You got points, many points. That is Q1, Q2, Q3, Q3. Like that you got. If you plot all points, you will get a contour. It will encircle the origin twice in the anti-clockwise direction because you are taking this contour in the clockwise direction. Suppose I am having no poles inside. All poles are outside. The pole is outside. The poles are outside. I am selecting a contour. If you do the mapping, it will not encircle the origin. It will not encircle the origin. The mapping is outside. The Q plane, if you see that, the mapping is outside. Suppose I'm having 1, 0 inside. I'm having 1, 0 inside. So far, pole we have seen. You are doing the mapping in the clockwise direction. You are doing the mapping in the clockwise direction. The mapping will be also in the clockwise direction. The origin will be encircled in the clockwise direction. For pole, it encircle in the anti-clockwise direction. For 0, it encircle in the clockwise direction. Suppose I am having two poles and 1, 0 inside. It will encircle only once. One pole and 1 0 will be getting cancelled. The difference only it will encircle. The difference is only 1 pole. That's why it will encircle the origin the anti-clockwise direction once. But you are doing the contour is selected in the clockwise direction means it will encircle the origin in the anti-clockwise direction once. Suppose I am having two zeros inside and one pole. What will happen? These two are getting cancelled. These two are getting cancelled. One, it means the difference is 0 only exceeds. That's why it will encircle in the clockwise direction. It will encircle the origin in the clockwise direction. That is the fundamental for Nyquist plot. Now, by having this fundamental, we can understand the Nyquist stability criterion. Nyquist stability criterion. I'm having a Q of S is equal to 1 plus G of S H of S equal to 0. What is 1 plus G of S H of S equal to 0? 1 plus G of S H of S equal to 0 is what? Characteristic polynomial. Denominator polynomial of a closed loop system. Am I correct or not? You see that closed loop transfer function? 1 plus G of S H of S. 1 plus G of S H of S in the denominator. For that, we are going to do the mapping. That is Q. That is Q. It means what? We are substituting the set of points on 1 plus G of S H of S. If any zeros inside that contour, it will encircle the origin once in the clockwise direction. Suppose I am selecting a contour such a way that the entire right hand side plane is taken. The entire right hand side plane is taken. It means I am taking up to J infinity. Here I am taking up to minus J infinity. I am taking a circle of radius infinity. It means what? The entire right hand side plane is taken as contour. All points on the contour is substituted in Q of S. You are doing the mapping. You are doing the mapping. If any poles on the right hand side, it will encircle the origin that many times. If doesn't encircle, it means no poles on the right hand side. No poles on the right hand side. That's why the system is stable. No poles, no zeros on the right hand side. Therefore, the system is stable, we can say. Suppose I am having characteristic equation, not Q of S is not a transfer function. It is a characteristic equation. Characteristic equation means you can simplify this like this 1 plus, suppose I am having G of S, H of S equal to 1 by tau S plus 1. If you take LCM, what you will get? Q of S equal to what? Q of S equal to characteristic polynomial will be tau S plus 1, tau S plus 1 plus 1. That is numerator become tau S plus 2. Am I correct or not? The numerator is the characteristic polynomial. Am I correct or not? Because characteristic polynomial you are equating to 0. That's why the denominator becomes 0. We are assuming we are taking only numerator. If we take the characteristic polynomial, we should talk about the numerator of Q of S. The numerator, that is zeros of Q of S should not be on the right hand side. Am I correct or not? Very difficult to digest. Because so far we have seen that the poles should not be on the right hand side. But one for Q of S, that is 1 plus G of S, numerator is the numerator is the denominator polynomial. You see 1 plus G of S, H of S, take LCM and equate to 0. This becomes numerator only. Characteristic polynomial means numerator only. What is characteristic polynomial? It is nothing but denominator polynomial of closed loop system. Therefore, the zeros of characteristic polynomial means it is closed loop poles. Zeros of characteristic, this line alone you remember. This line alone you remember. Zeros of characteristic polynomial are closed loop poles. Zeros of characteristic polynomials are closed loop poles. In other words, zeros of Q of S are closed loop poles. Zeros of Q of S are Q of S equal to what? 1 plus GH. The numerator of 1 plus G of S, H of S is the characteristic polynomial. Therefore, zeros of Q of S are closed loop poles that should not be on the right hand side. That's why if you do the mapping, it is not yet over. Nyquist stability criterion is not yet over. What we have taken 1 plus G of S, H of S equal to 0. Instead of taking like that, add -1 on both sides. What you will get? G of S equal, H of S equal to -1. Am I correct or not? If you see 1 plus G of S, H of S equal to 0 means whether you are encircling 0 or not. 0 is replaced by -1. That's why whether it encloses -1 or not, we have to check, not 0. So if you check for G of S, H of S, if you check for G of S, H of S, it should not encircle -1. It should not encircle -1. That is Nyquist stability criterion. 0 is replaced by -1. 0 is replaced by -1. That is, you are shifting the plot about 0 to about -1. That is the meaning. That is the meaning. If you shift the graph about origin to about -1 means we need not check whether it encircles 0. Instead, we have to check whether it encircles -1. But if it is checked for -1, whether it encircles -1 or not, if we check, then we can check directly for open loop transfer function. No need to go for closed loop transfer function. Because we are not checking for origin. We are checking for -1. That's why we can check for G of S, H of S. We can check for G of S, H of S. We know that in the S plane, if we select a pole is enclosed by a contour. This is enclosed by a contour C. If you do the mapping on Q of S, you will get a mapping in Q plane. This plane is called Q plane. This axis is called real part of Q. This axis is called imaginary part of Q. Don't put sigma j omega. In the S plane only it is sigma j omega. This plane is called Q plane. In Q plane, x-axis is called the real part of Q. Y-axis is called the imaginary part of Q. Here, this Q of S has one pole here. This P1 is here. I am selected a contour such a way that it encloses the P1. If you do the mapping on Q plane, it means what? Select some points on this contour and substituted in Q of S, you will get some set of points. That point is plotted here that will encircle the origin in the anti-clockwise direction. In the anti-clockwise direction. Here you select which direction you plotted in the clockwise direction, it encircles in the anti-clockwise direction. The origin is encircled. Suppose I'm having two poles inside that contour and mapped in the clockwise direction, S plane. In the Q plane, if you do the mapping on Q of S, it means substitute these points, the points on the contour in Q of S, and get some points here that will encircle the origin twice in the anti-clockwise direction. Twice in the anti-clockwise direction. This is called Q plane. Q plane, this is called real part of Q. This is called imaginary part of Q. Suppose I'm selected a contour such a way that two zeros are there inside. If you do the mapping in the clockwise, if you select the contour in the clockwise direction of S plane, and if you do the mapping on Q plane, it means you have to substitute these points on the contour in Q of S and get the complex points. This plane is called the Q plane. This is called the real part of Q. This is called the imaginary part of Q. It will encircle the origin in the clockwise direction. The clockwise direction twice because two zeros are inside. This is also in clockwise. This is also in clockwise. Suppose I'm having one pole, 1, 0 inside the contour. One pole, 1, 0. Here, the mapping will not encircle the origin. Will not encircle the origin. Suppose here, I'm having here, I'm having two poles, 1, 0. 2 poles, 1, 0 in the inside the contour means it will encircle the origin in the anti-clockwise direction only once in the Q plane. This is taken in S plane. Because the difference is n minus m. Always m is less than n. N minus m. How many poles inside? How many zeros inside? The difference is n minus m. P minus Q. Number of poles on the right hand side will be called as P. Number of zeros on the right side are called Q. P minus Q times it will encircle the origin. How many inside? 3. But 1 pole, 1, 0 getting cancelled. That's why it will encircle the origin in the anti-clockwise direction. This is the basic concept for Nyquist contour, Nyquist stability criterion. This is mathematics. This is mathematics. This will be applied for stability analysis of control system. For that, let us take one system. To understand this, let us take a simple first order system. The first order system Q G of S equal to K upon tau S plus 1. This is the first order system. What is the closed loop transfer function? K upon tau S plus 1 plus K. For a closed loop system to be stable, poles of this denominator polynomial should not be on the right hand side. Am I correct or not? The poles are roots of this characteristic equation should not be on the right hand side. Should not be on the right hand side. Roots of this characteristic equation. The characteristic equation, how we can find 1 plus G of S, H of S equal to 0. What is that? Here in this case, H of S equal to 1, let us assume. In this case, H of S equal to 1. So 1 plus G of S, that is K upon tau S plus 1 multiplied by 1 equal to 0, or what you will get if you take LCM, what you will get? Tau S plus 1 plus K upon tau S plus 1 equal to 0. This is characteristic equation. Characteristic equation. Equal to 0 means what is the meaning of denominator? Equal to 0 means what is the meaning of denominator? It's nothing but 0. If you bring this to the right hand side, it's 0. But we can tell like this. Can we tell like this? So this numerator is roots of numerator of Q of S are roots of closed loop transfer function. Am I correct or not? If you consider Q of S directly, numerator polynomial only, not denominator polynomial. That's what I said in the previous class. Because we are not taking closed loop transfer function, we are taking characteristic polynomial, 1 plus G of S, H of S. If you take that, the characteristic polynomial is actually we will bring this to the right hand side and we will write this only, characteristic polynomial. But I am deliberately keeping the denominator. So the numerator polynomial is the roots of closed loop transfer function. Numerator polynomial, not denominator polynomial. So I can say that 1 plus G of S, H of S equal to 0, if I consider that the numerator polynomial of this is characteristic polynomial. Numerator of this is roots of this numerator polynomial is closed loop poles. Am I correct or not? Roots of this, roots of numerator polynomial equal to closed loop poles. As far as Q of S is concerned, not transfer function. If you consider transfer function only denominator polynomial, Q of S is 1 plus G of S H of S. So, if you, from this what we can understand is, what is the denominator? What is the denominator of 1 plus G of S H of S? If you see the denominator of this and the denominator of closed open loop transfer function are same. Denominator of open loop transfer function and the denominator of Q of S are same. But numerator of Q of S is denominator of closed loop transfer function. So I can say that Q of S has, if you consider Q of S equal to Q of S equal to open loop denominator. Can I write like that? Because the open loop denominator of this and this are same. 1 plus G of S H of S, whose open loop denominator and G of S denominator are same. So denominator is open loop denominator. But numerator is what? Closed loop denominator. Closed loop denominator. Can I say like that? Why? Because closed loop is the characteristic polynomial. The numerator is characteristic polynomial. Numerator is characteristic polynomial. That's why it is nothing but closed loop denominator. That is characteristic polynomial. So Q of S has numerator is closed loop denominator. Denominator is open loop denominator. Open loop transfer function denominator. Open loop transfer function denominator. This is transfer function denominator. So if Q of S equal to 1 plus G of S H of S equal to what you got? 1 plus K upon tau S plus 1 multiplied by 1, that is equal to 1 tau S plus 1 plus K divided by tau S plus 1. What is open loop transfer function? G of S K upon tau S plus 1. The denominator polynomial of open loop transfer function and the denominator polynomial of Q of S are same. In other words, the denominator of Q of S is denominator of open loop transfer function. What is numerator? Numerator is denominator of closed loop transfer function. Numerator is denominator of closed loop transfer function or characteristic polynomial. Characteristic polynomial. So for a system to be stable, for a closed loop system to be stable, the roots of characteristic polynomial should not be on the right hand side. That is, roots of denominator of closed loop transfer function should not be on the right hand side, or numerator of Q of S should not have any roots on the right hand side. All are same. So I am telling in three ways. One is roots of characteristic polynomial should not on the right hand side. The same can be said as roots of denominator polynomial of closed loop transfer function should not be on the RHS. The same can be said, roots of numerator polynomial of Q of S should not be on the right hand side. All are same. All the three statements are same. Roots of characteristic polynomial should not be on the right hand side for a closed loop system to be stable. Roots of denominator polynomial of closed loop transfer function should not be on the right hand side. That is also same. Roots of numerator polynomial of Q of S, because roots of numerator polynomial is nothing but characteristic equation. Characteristic equation. So, if you do the mapping for 1 plus G of S, H of S, if you do the mapping for 1 plus G of S, H of S, by selecting the contour such a way that that contour encloses the entire right hand side plane, so that if any point on the right hand side is roots of that characteristic polynomial, then it will encircle the origin. It will encircle the origin. For example, I am taking the contour like this. Up to J infinity, I am selecting. This contour, its radius is infinity. It varies from plus 90 to minus 90. Then we are taking this part. This segment is called C1. We are doing mapping for C1. Then we are doing mapping for C2. Then we are doing mapping for C3. If you do this contour, if any of its roots on the right hand side, it will encircle in the clockwise direction once, because 0 means it will in the same direction. We are doing mapping for Q of S, not the transfer function. That's why if it encircles in the clockwise direction once, therefore one pole is on the right hand side unstable, because the contour is the entire right hand side plane. The contour is entire right hand side plane. Suppose two poles on the right hand side means it will encircle in the origin twice in the clockwise direction. S minus 1, so that it will be simple. S minus 1, stable system or unstable system? Open loop unstable system, because pole is on the right hand side. If you draw, where is the pole? P1 equal to 1 plus 1, therefore unstable system. What is the root locus? This is plus 1. The root locus will be like this. It will cover the entire, if you k equal to 0 here k equal to infinity. This is the root locus. But if you increase k, after some time it becomes stable. Are you able to notice that? If you increase k, it becomes stable. In closed loop, it becomes stable. In open loop, it is unstable. Open loop, it is unstable, but closed loop, it is stable. Can you give any example for open loop, unstable, and closed loop stable system? Practical system. Bicycle or bike. If it didn't ride, stable or unstable? Unstable. If it didn't ride the cycle, it is unstable, it will fall. If you ride, it is closed loop system. What you are doing is, you are adjusting this side or that side. That's why you are turning the handlebar. To turn the cycle this side, suppose if it is falling this side, means you will turn this side. It means you are raising its level to vertical. If it falls this side, you are turning the opposite way. That's why it comes to again vertical. That's why if handlebar is locked, it will not, you cannot make it vertical. So in closed loop, it is stable. Open loop, it is unstable. Like that, this system is open loop unstable. This is open loop unstable. But in closed loop, it is stable. Let us consider this. What is the closed loop transfer function? T of S equal to, what is T of S equal to what? Closed loop transfer function is S minus 1 plus K. Am I correct or not? This is the closed loop transfer function. This is the denominator polynomial of closed loop system. Denominator polynomial of closed loop system. Find Q of S. Q of S equal to what? 1 plus K upon S minus 1 multiplied by 1. That is equal to what? 1 plus k by s minus 1. If you take LCM, you will get s minus 1 plus k. If you consider q of s, that is characteristic polynomial. Q of s means characteristic polynomial. The closed loop denominator polynomial becomes numerator of q of s. That's why it should not encircle the origin in the clockwise direction. It means it has some poles on the right hand side. Okay, now you understand. But there is no change in the denominator. You notice that there is no change in the denominator. So if you do the mapping for this, with considering the entire right hand side plane, this plane is called, this contour is called this Nyquist contour. Nyquist contour. Nyquist contour is in which plane? S plane. Nyquist contour is in S plane. I am taking a Nyquist contour and do the mapping. If I do the mapping, Q of S is what? S minus 1 in the denominator. That's why if you do the mapping, one pole on the right hand side. But here, no zeros on the right hand side. No zeros on the RHS. Let us assume. No zeros on the right hand side means stable system. Am I correct or not? Because numerator is closed loop poles. Numerator of Q of S is closed loop poles. That's why no zeros on the right hand side of Q of S. It means no closed loop poles on the right hand side. But denominator, one pole on the right hand side. That's why the mapping will encircle 0 in the anti-clockwise direction once. Now I can say that system is stable because it is not cancelling. No poles on the right hand side. Only one pole in the no zeros on the right hand side. No zeros on the right hand side. But only one pole in the open loop pole is on the right hand side. That's why it will encircle only once. Therefore, system is stable, I would say. It means one open loop pole is on the right hand side. That's why this encirclement. Suppose two poles on the right hand side. Two open loop poles are on the right hand side, but no zeros on the right hand side means it will encircle twice in the anti-clockwise direction. Again, it is stable. Suppose if I am taking a stable system, I think you understand this. Understand this, or once again, shall I tell? What is this? G of S equal to K upon S minus 1. This is open loop stable or unstable? Open loop unstable. What is the characteristic polynomial? S minus 1 plus K. For some values of K, the poles will be on the left hand side. Because if you see the root locus, if you K increase, it comes to the left hand side. We know that some K values of K, it will become a stable system. So, for a particular value of K, I want to check the stability. So, I am drawing the root locus for closed loop system. That's why I mapped the entire right hand side plane with Q of S. If you see that, the numerator of Q of S is the characteristic polynomial. That's why the roots of characteristic polynomial should not be on the right hand side. No zero should be on the right hand side. No zero should be on the right hand side. It should not encircle in the clockwise direction. But it will encircle once in the anti-clockwise direction. Why? Because the denominator of Q of S is S minus 1. That is fixed. One pole is on the right hand side. One open loop pole is on the right hand side. That's why it will encircle only once in the origin. Therefore, the system is stable. Suppose it is not encircling. What is the meaning? If it is not encircling, what is the meaning? It means some zero is on the right hand side getting cancelled. That's why it is not encircling. It is not encircling. Therefore, the system is unstable. Suppose it comes like this. It is not encircling means it should encircle for open loop. For closed loop, it should not encircle. Therefore, the open loop must exist here. That is, in the anti-clockwise, it should exist. It doesn't exist. Therefore, unstable. Suppose I am having on the other hand, I am taking a stable system. Suppose I am taking a stable system. Then what happens? Let us see. The mathematics, the mathematical background behind this is, if you consider a Nyquist contour. What is Nyquist contour? Nyquist contour is considering the entire RHS is the Nyquist contour. This is called Nyquist contour. This contour encircles the entire right side plane. Here, this goes up to J infinity. The radius of this semicircle is infinity. Its angle varies from plus 90 to minus 90. That is plus pi to minus pi. Here, it comes to minus J infinity, then comes to 0. Therefore, the contour is the entire RH plane. For this, this contour is mapped on G of S. Q of S, let us say Q of S. This is mapped on the Q of S. You will get a plot. Suppose Q of S is like this. Some two poles are on the right hand side. That is minus plus 1 plus 2 is there. That is K upon S minus 1 and S minus 2 is Q of S. If you do the mapping of this Nyquist contour, the mapping is called in Q of S plane. This is in what? S plane. The Nyquist contour is in S plane. That is mapped in the Q of S plane. Q of S is K upon S minus 1 multiplied by S minus 2. If you do the mapping, it will encircle the origin of Q of S plane, real part of Q of S. This is real part of Q of S. This is imaginary part of Q of S. The mapping will be encircle the origin in the anti-clockwise direction twice. Why? Because two poles are on the right hand side. Two poles are inside that contour. That is on the right hand side. It will encircle in the anti-clockwise direction. Similarly, suppose Q of S is like this. S minus 1 multiplied by S minus 2, S plus 2, S plus 3. This is the transfer function. If you do the mapping on this Q of S, what you will get is, again, in the Q of S plane, it will encircle the origin in the clockwise direction twice. In the clockwise direction twice. How to say the direction? Because here we are doing the mapping in the clockwise direction. It gives the values in the anti-clockwise direction. That's why it is encircle the origin in the anti-clockwise direction. Again, we are considering in the clockwise direction only. It is also in the clockwise direction. The values will move in the clockwise direction twice, because two zeros are inside the contour, that is on the right hand side. Suppose I am having another system in that is Q of S. The mapping is done for this entire right hand side plane. The contour is up to infinity. Here up to minus J infinity. Its radius also infinity. I am selecting Q of S such a way that K of S minus 1, S plus 2 upon S minus 3, S minus 4. 1, 0 is at minus 1. 1, 0 is at minus 1. And one pole, or two poles are there. That is one at -3. Another one is at -4. Therefore, if you do the mapping, that is substituting all points on the contour in Q of S, you will get another contour here in the Q of S plane. Here, it will encircle how many times? 1, 0 and 1 pole will be getting cancelled. That's why it will encircle in the anti-clockwise direction only once. Why? In the first case, number of poles equal to number of right hand side poles. P is number of right hand side poles. P equal to 2. That's why it encircle the origin in the anti-clockwise direction that many times, 2 times. Here, number of zeros is 2. Z equal to 2. Only we are talking about P and Z here. Definition is whatever on the right hand side, that is inside the contour. So here 2 zeros are inside that contour. That's why Z equal to 2. But P equal to 0 here. P means not number of poles. Poles on the inside the contour or on the right hand side. P equal to 0. That's why it will encircle the origin in the clockwise direction twice. In the third case, Z equal to 1, P equal to 2. That's why the difference is P minus Z equal to 2 minus 1 equal to 1. That's why it encircle, that is P is dominating. That's why it will encircle in the anti-clockwise direction only once. So this is the mathematical basis already we have seen. Now let us consider 1 plus G of S. 1 plus G of S, H of S. For a unity feedback system, you can include H of S also. What is this? This is characteristic equation. Characteristic equation. This is the characteristic equation. Suppose I am having system K upon S plus 1 is the system. What is the characteristic equation? 1 plus and H of S equal to 1. H of S equal to 1. This is the G of S. This is H of S. Therefore, 1 plus G of S, H of S. This is characteristic equation is 1 upon S plus 1 multiplied by 1. That is equal to, we have to consider K. I put 1, K. K upon S plus 1 multiplied by 1. If you simplify this, what you will get? S plus 1, in the numerator you will get S plus 1 plus K. S plus 1 plus K. What is denominator? You notice that denominator of 1 plus GH and denominator of open loop system are same. What is numerator? Where? Yes. Yes, thank you. This is plus 3, plus 4, plus 4. Yes. Plus 1, plus 3, plus 4. The poles are positive values I have to enter. Okay. What I am saying is correct. Thank you. Plus 1, plus 3, plus 4. Okay. Here, we have to understand that in a characteristic equation, denominator polynomial is open loop denominator. Open loop denominator. What is numerator? Numerator is closed loop denominator. You find the closed loop transfer function for this. What you will get? This is the transfer function, means there is no change in numerator. Denominator is sum of numerator and denominator plus K. This is T of S. You see that T of S equal to K upon S plus 1 plus K. So in a characteristic equation, numerator is the roots of numerator is closed loop poles. In other words, it is characteristic equation. In a characteristic equation, numerator polynomial gives closed loop poles. Am I correct or not? In a characteristic equation, numerator gives closed loop poles. Denominator gives open loop poles. So I can say that in 1 plus g of s h of s, the numerator gives closed loop poles. Denominator gives open loop poles. What we have to check for a closed loop system to be stable, the contour CGH. For what we are doing mapping? For GH only. Here we did the mapping for GH. We did the mapping for GH. That's why this mapping is called GH mapping. This contour is called CGH. That's what here it is written. If the contour CGH of the loop transfer function G of S, H of S in the GH plane corresponding to Nyquist contour, this is the Nyquist contour. In the S plane, n circles the point -1 plus j0 in the counterclockwise direction, that is anti-clockwise direction, as many times as the right of S plane poles of G of S, H of S. It means P number of times it should encircle. Then the closed loop system is stable. So the n must be equal to P. This way also you can remember. P must be equal to n. P in the last case, P equal to 2, n also equal to 2, therefore Z equal to 0. So P must be equal to n. That way also you can remember. System shown in figure. Sketch the Nyquist plot. Roughly, for all Nyquist plot, you have to draw roughly, not on the graph sheet. You cannot draw because we have to draw at infinity. Some points we have to plot at infinity. That's why it's not possible to draw at scale. For k equal to 2, the value of k is given. Use the Nyquist criterion to determine whether the closed loop system is stable for this gain k equal to 2. Find the range of k for the system to be stable. Here, the open loop transfer function is this. Open loop transfer function G of S equal to 2 multiplied by 1 minus S upon S plus 2, S plus 3. What is P? P is open loop poles on RHS, that is equal to 0. P equal to open loop poles on the right hand side, that is equal to 0. No open loop poles on the right hand side. But we do not know Z equal to, we do not know. Is there any open closed loop poles on the right hand side? That we have to find. N is, we have to find number of encirclement with -1 plus j0. -1, that is -1 plus j0. Encirclement. Here, this is the Nyquist contour. This is the Nyquist contour. For this Nyquist contour, it is in the clockwise. It is considered in clockwise direction. It has 3 segments. One is C1, that is from 0 to J infinity. Omega varies from 0 to infinity, that is 0 to J infinity. Another segment is second segment, that is R e power j theta. R tends to infinity. Theta varies from plus pi by 2 to minus pi by 2. Semicircle of radius infinity. Second segment. Third segment is minus j infinity to 0. So minus j infinity, that is omega varies from infinity, minus infinity to 0 minus. Here this is 0 plus. 0 plus means towards positive side. 0 minus means towards negative side. That is the meaning. This is up to 0 minus, this is up to 0 plus. Here, this Nyquist contour is in the clockwise direction. If you assume this as positive direction, if you consider the same direction of Nyquist contour, then it is positive. Same direction, n is positive if same direction as Nyquist contour. N is negative if opposite to Nyquist contour, that is anti-clockwise direction. This is clockwise direction. Therefore, Z equal to P plus N. Z equal to P plus N. Z must be 0. For the system to be stable, Z must be 0. That we have to check whether Z is 0 or not. That we have to check. Now, we have to map this Nyquist contour on this system. Nyquist contour we have to consider. This is the Nyquist contour. That has to be mapped on 2 multiplied by 1 minus S upon S plus 2 multiplied by S plus 3. Here, P equal to 0. Therefore, N must be 0 for stable system. If P equal to 0 and N equal to 0, then automatically you will get Z equal to 0. So we have to get the N equal to 0. If N equal to 0, automatically Z also will be 0. Therefore, the system will be stable. If you map this on this, you will get Nyquist, you will get the CGH plot. CGH plot, that is called a Nyquist plot. Nyquist plot you will get. Nyquist plot you will get. To do that, this Nyquist contour has 3 segments. Already I said C1, this is C2, this is C3. Let us do the mapping one by one. First, let us do the mapping for C1. Mapping for C1. Mapping for C1. That is, omega varies from 0 to infinity. 0 plus to infinity. Omega varies from 0 to infinity. What is G of S equal to K equal to 2, 1 minus omega, 1 minus S upon S plus 2, S plus 2 multiplied by S plus 3. Therefore, G of J omega equal to 2 multiplied by 1 minus J omega upon J omega plus 2 multiplied by J omega plus 3. Therefore, modulus of G of J omega equal to 2 square root of 1 plus omega square upon square root of omega square plus 4 square root of omega square plus 9. What is the angle of G of J omega? Angle of G of J omega equal to, for this, minus omega, but it is in the numerator. That's why plus tan inverse of minus omega by 1. Minus, it is in the denominator. This is in the denominator. That's why minus tan inverse of omega by 2 minus tan inverse of omega by 3. That's all. These are the 3 terms. There, angle of 2 is 0. So now, it has numerator polynomial as well as denominator polynomial. That's why we cannot draw the rough diagram by using conventional thumb rule. What is thumb rule? Thumb rule says if it is first order system, this is the Nyquist polar plot. If it is second order system, the type 0 system, second order type 0 system, this is the plot. Type 1 third order system, this is the plot. These are all we know, but we cannot apply those rules here. We cannot apply because the numerator, it must have k only. It must have k only. Then only these rules we can apply. Here it has numerator polynomial. That's why we cannot apply that rule. That's why we have to form a table and find various values. We have to form a table and we have to find various values. Omega, modulus of g of j omega, and angle of g of j omega. Omega will not be useful to plot, but it will be useful to find the modulus of j of j omega and angle of j of j omega. When omega equal to 0, if you substitute omega equal to 0 here, you will get 2 by 6. That is 1 by 3. That is 0.33. 0.33 is the magnitude. If you substitute omega equal to 3 here, omega equal to 0 here, you will get 2 by 6. That is 0.33. What is the angle? If you substitute omega equal to 0, omega equal to 0, omega equal to 0 here, the angle is 0. When omega equal to infinity, what is the angle and magnitude? When omega equal to infinity, what you will get? You will get 0. 0 or substitute omega equal to infinity, as he said, infinity by infinity undefined. Yes. But what is g of j omega square? That is equal to 2 1 plus omega square divided by omega square plus 4 and omega square plus 9. So if you differentiate the numerator and denominator, what you will get? 4. Yes. Thank you. 4 multiplied by 1 plus omega square. Okay. Now, infinity by infinity form, undefined. That's why differentiate the numerator and denominator with respect to omega. Before that, we have to convert this into polynomial. That is omega power 4 plus 13 omega square plus 36. So if you differentiate this, what you will get? 4 multiplied by 2 omega. Here you will get 4 omega cube plus 26 omega plus 0. Again, infinity by infinity form. That's why again differentiate the numerator denominator. 8 upon 12 omega square plus 26. So if you substitute omega equal to infinity, you will get 0. This you need not check. If numerator degree is higher than, denominator degree is higher than numerator degree, then we can put 0 immediately. Because limiting case, it will become 0. That's why this magnitude is 0. What is the angle? Angle, tan inverse of minus omega is minus tan inverse of omega. That we know. Therefore, if we substitute here infinity, minus 90, minus 90, minus 90. Therefore, you will get for this also, because of this minus omega, for this also, it becomes minus. Therefore, minus 270. But second order system, how we got for conventional, for numerator polynomial is absent means, what is the second order polar plot? It will be like this. It ends at minus 180. But here it ends at 270 because of numerator, that too with the right hand side 0. If the left hand side means it will end at minus 90, like first order. So that's why if numerator polynomial is there, we cannot say. Similarly, if right hand side poles and 0 is there, we must be careful because the angle will be changed. So these rules we can apply only if there is no numerator polynomial, first condition. Second condition, all poles must be in the left hand side. Then only we can apply all these rules. So minus 270. You find the intermediate values here. Intermediate values here. If you find the intermediate values, here omega equal to 1, you have to find 2, 3, like that we have to find. Let us copy from there. Okay. Let us find, before finding some values, you have to find some values. It's not available. You find yourself 1, 2, 3, 10, 100, 1000, like that, 1500, like that you find. Before that, whether it crosses, where it crosses the negative real axis, that we have to find. To find that where it crosses negative real axis, then only, because the plot starts at 0.33 angle 0, and end at 270 here. End at origin at 270, minus 270. That's why it must come like this. It must come like this. These some points you can find from the table. But where it crosses the real axis, where it crosses the real axis, that we have to find. To find that, we have to consider g of j omega. G of j omega equal to 2 multiplied by 1 minus j omega upon 2 plus j omega multiplied by 3 plus j omega. Multiply the numerator and denominator by complex conjugate. If you multiply the numerator and denominator by complex conjugate, you will get in the denominator 4 square plus 1, sorry, 2 square plus 1 and 3 square, that is 4 plus 1, and here you will get 9 plus 1. The numerator you will get 2 multiplied by 1 minus j omega. Sorry, this is omega square, you know, omega square. In the numerator you will get complex conjugate of this is 2 minus j omega multiplied by 3 minus j omega. Denominator is pure real. That's why to find the point of intersection, here imaginary part equal to 0. Imaginary part equal to 0. Imaginary part equal to 0. The point of intersection here, what is the condition? Imaginary part equal to 0. That's why we are multiplying the numerator denominator by complex conjugate. Now the denominator becomes pure real, and the numerator consists of both 6. What is that? 6 minus 6 omega square plus j omega cube minus 11 omega. So this is 4 plus omega square, 9 plus omega square. So here the imaginary part equal to 0. That is omega cube minus 11 omega equal to 0. To find the point of intersection with the real part, the real axis, that is omega multiplied by omega square minus 11 equal to 0, or omega equal to, therefore omega equal to 0 comma square root of 11 plus or minus square root of 11. that is equal to 0, 3.3. When omega equal to 3.3, it intersect it crosses the real axis. It crosses the real axis. So what is the magnitude at omega equal to 3.3? That we have to find. Therefore, g of j omega equal to 2 multiplied by square root of 1 plus omega square divided by square root of 4 plus omega square root of 9 plus omega square, where omega equal to 3.3. If we substitute 3.3, the value is 0.4. So it intersects the real axis at 0.4. It intersects the real axis at 0.4. What is the angle? Angle 180 minus 0.4. Therefore, minus 0.4. We got only magnitude. Modulus of g of j omega only we got minus 0.4. It intersects the real axis at minus 0.4. If we substitute omega equal to here, the angle criterion, if you substitute omega equal to 3.3, you will get angle 180 degree. So minus 0.4. Minus 0.4. So we plotted for 0 to infinity. Now we have to plot the second segment. What is the second segment? Second segment is, this is the second segment. This is the second segment. That segment can be mathematically defined like this. Omega equal to R, limit R tends to infinity, limit, mathematically it can be defined like this. Limit R tends to infinity, R e power j theta, and theta varies from minus plus pi by 2 to minus pi by 2, or plus 90 to minus 90 degree. Here you see that here the angle is plus 90, here minus 90. The angle is here plus pi by 2, minus pi by 2. The radius is infinity. Therefore, mathematically, we can define the circle like this. Limit R tends to infinity, R e power j theta. Angle varies from. So this semicircle can be defined as limit R tends to infinity, R e power j theta. G of j omega equal to G of j omega equal to 2 multiplied by 1 minus omega divided by 2 plus j omega multiplied by 3 plus j omega, where omega equal to R e power j theta. That is equal to 2 1 minus R e power j theta upon 2 plus j R e power j theta, 3 plus j R e power j theta. If you take R e power j theta outside, what you will get? 2 R e power j theta 1 by R e power j theta minus j whole divided by 2 plus, if you take 2 R's, therefore R square, you will get R square. E power j theta also 2 you are taking, e power j 2 theta. So 2 by R e power j theta plus j 1, that is j. Again 3 divided by R e power j theta plus j. So as R tends to infinity, here we have to put limit R tends to infinity, we have to put. While substituting, we have to put limit R tends to infinity. If you let R tends to infinity, if you let R tends to infinity, these are all becomes 0. These three terms become 0. Only these two terms will be there. These two terms will be there. Then if you substitute R equal to infinity, you will get here R square. If you substitute infinity, infinity by infinity. But a limiting case, it will be 0. As a limiting case, it becomes 0 because denominator polynomial is higher than numerator polynomial. Therefore, magnitude is 0. As a limiting case, we are not going to say 0. Instead, we are going to say it is epsilon. Limit epsilon tends to 0. Epsilon tends to 0. You need not put this limit also. Epsilon tends to 0 and the angle we have to write. Angle we have to write. That is, here the angle is here 2 theta. Here theta. That's why this angle varies from j theta e power j theta multiplied by e power minus j2 theta. So we have to add the numerator, the powers. That's why you will get e power minus j theta. So the angle varies from, what is the Nyquist contour angle? Pi by 2 to minus pi by 2. If you substitute here that minus pi plus pi by 2, it becomes minus pi by 2. Therefore, theta varies from minus pi by 2 to plus pi by 2, opposite because of this negative sign. But anyhow, epsilon is 0. Its angle varies means that point is rotating like this. That is the meaning. That point is rotating like that from minus pi by 2 to plus pi by 2. That direction is important. This point is rotating from minus pi by 2 to plus pi by 2. Like that, it is rotating. But anyhow, the magnitude is 0. That's why it remains at this point. It remains at this point, but angle only varies. Therefore, always don't worry R e power, while substituting R e power j theta, magnitude is always 0 unless denominator polynomial is less than numerator polynomial. If denominator polynomial is higher than numerator polynomial, always its magnitude is 0. That's why no plot for that infinite radius. Always it is 0. Its magnitude is always 0. That's why its mapping is coming at the origin only. Its mapping is coming at the origin only. Now we have to map for the final segment, that is C3. If you do the mapping for C3, earlier, what is the value of omega varies from 0 to infinity, 0 plus to infinity. Now it varies from minus infinity to 0 minus. Therefore, it is nothing but mirror image of this. That's why no need to do the mapping. That's why we got this plot. So mapping of C3 is mirror image of mapping of C1 always. So what is required? Only polar plot is required. If you know the polar plot, you have to draw the mirror image of polar plot. That's all. Mirror image of polar plot, you will get Nyquist plot. So the simplest way to remember Nyquist plot is, first we have to draw the polar plot as omega varies from 0 to infinity. After drawing the polar plot, draw the mirror image of that plot, you will get Nyquist plot, unless otherwise there is no S term. If S term is there, small change is there, that we will see in the next sum. If there is no S term here, there is no S term here, S term in the denominator. If it is there, you will get one more segment that you will see in the next sum. So now we got the Nyquist plot. Nyquist plot we got, it intersects the real axis at point, 0.4, minus 1 is here, minus 1 plus J0 is here, it doesn't encircle, therefore n equal to 0, n equal to 0 for k equal to 2, n equal to 0, p also equal to 0, therefore z equal to no encirclement, n equal to 0, n equal to 0, p also equal to 0. P means what? Number of open loop holes on the right hand side. That is 0 because what is given? The given open loop transformation S plus 2 and S plus 3. That is poles are minus 2 and minus 3. That is in the left hand side. Therefore, P equal to 0. No encirclement because it intersect before minus 1. It intersect before minus 1. Therefore, at minus 0.4. That's why it is not encircling minus 1, n equal to 0. Therefore, z equal to n plus p, that is equal to 0 plus 0 equal to 0. Therefore, the given system is stable. What is second part in this question? Find the range of k for the system to be stable. Find the range of k for the system to be stable. We know that if you increase k, its size will increase. The plot size will increase. That's why as k increases, this point will move to minus 1. 0.4 will come here as k increases. How much k we have to increase? What is the factor by which this 0.4 when k equal to what? 0.4 k equal to 2, not k equal to 1. We have to draw to find the range of k. We should plot for k equal to 1. That already I told you. That 0.4 must be divided by 2. That is equal to 0.2. Or if you substitute, instead of 2, if you substitute k, what you will get? In the modulus of this value, instead of 2, if you substitute k, that here what you will get is 0.2k. 0.2k, we have to make it is equal to 1. Then it will pass through that minus 1. Therefore, k equal to 1 by 0.2. That is equal to 5. 1 by 0.2, that is equal to 5. When k equal to 0, what happens? This point comes here, coincides with the origin. Therefore, k must varies from 0 to 5. The open loop transfer function of a unity feedback system is given by g of s h of s equal to 5 upon s multiplied by s plus 1 multiplied by s plus 2. Draw the Nyquist plot and hence find out whether the system is stable or not. In this case, because of this S, the Nyquist contour is different. What is the Nyquist contour? Nyquist contour is contour C1. It varies from 0 plus to J infinity. That is C1. Then a semicircle of radius infinity from R e power j theta. R tends to infinity and theta varies between pi by 2 and minus pi by 2. There is the second segment C2. The third segment is from minus j infinity to 0 minus. That is the third segment. In this sum, because of this S is at the origin. That is 1 by S means a pole at the origin. That should be excluded because this Nyquist contour must be analytic. Analytic means it should not pass through any of the poles That's why we have to exclude that pole. So draw a semicircle about that pole of radius epsilon, similar to C2, its radius is epsilon e power j theta, as epsilon tends to 0 here. There is r tends to infinity, here epsilon tends to 0, and theta varies between minus pi by 2 to pi by 2. That is the difference. So this segment is called C4. We have to map C1, C2, C3, and C4 on the function g of s h of s. So if you map this on g of s h of s, what we will get, we have to see. So for that, the first step is we have to consider the mapping of C1. We have to consider the mapping of C1. C1 means omega varies from 0 to infinity. It is nothing but a polar plot. That's why we have to find g of j omega equal to 5 upon j omega plus 1, j omega plus 2. Modulus of g of j omega equal to 5 upon omega square root of omega square plus 1 square root of omega square plus 4. Angle of g of j omega equal to minus 90 for s. For this one, minus tan inverse of omega minus tan inverse of omega by 2. If we substitute omega, when omega tends to 0, the magnitude modulus of g of j omega tends to infinity. Angle of g of j omega equal to, if you put omega equal to 0, you will get minus 90. When omega tends to infinity, g of j omega, because there is no polynomial in the numerator, the only denominator polynomial, that's why it tends to 0. Omega tends to infinity, it tends to 0. Angle of g of j omega equal to 3 angles. This is minus 90. Omega tends to infinity means this also becomes minus 90. This also becomes minus 90. Therefore, minus 270. There is no numerator polynomial. That's why the polar plot, the plot for this is, it starts at minus 90, infinity, minus j infinity. It starts at infinity and it reaches 0 at 270 degree. That's why the plot will be looking like this. When omega tends to infinity, it reaches here. Real part of g of gh, real part of gh. This is real part, imaginary part of gh. So that the plane is gh plane. The plane is gh plane. This is in s plane. This is in s plane. So now we did the mapping for C1. Now we have to do the mapping for C2. That is mapping for C2. Mapping for C2. C2 is what? C2 can be mathematically defined as R tends to infinity e power j theta, and theta lies in between pi by 2 and minus pi by 2. This is the definition for C2. This we have to substitute in g of j omega. G of j omega equal to, the magnitude is here 5, 5 upon S. S means R e power j theta, R e power j theta plus 1, R e power j theta plus 2. If you take R e power j theta outside, what you will get is R cube e power j3 theta. Here 1 plus 1 by R e power j theta, 1 plus 2 R power e j theta. As R tends to infinity, here we have to include that limit R tends to infinity. Infinity. That is equal to this tends to 0. This is also tends to 0. This only this alone is there. R tends to infinity, it becomes epsilon, as epsilon tends to 0. Or you can put simply 0 e power minus j3 theta. Therefore, the angle varies from 3 times 90, that is minus 272, minus 272, minus 272 plus 270. It varies like that. So it is the mapping is like this. So anyhow, it is a point at origin, but its angle only varies. Its angle alone is varying. Therefore, its angle varies from 272 minus 272 plus 270. A point at origin. It is nothing but a point at the origin. Now mapping of C3. C3 is what? C3 means omega varies from minus infinity to 0 minus. So it is the mapping is mirror image of mapping of C1. Therefore, what is the mapping of C1? Mapping of C1 is this. This is mapping of C1. It will be a mirror image, means it will be like this. This goes to J infinity. Now we have to do the mapping for C4. Mapping of C4. Mapping of C4. C4 means what? Epsilon, as epsilon tends to 0, e power j theta. Theta varies from minus pi by 2 to plus pi by 2. Theta varies from minus pi by 2 to plus pi by 2. If you substitute here, g of j omega equal to as omega tends to epsilon e power j theta equal to 5 divided by epsilon e power j theta, epsilon e power j theta plus 1, epsilon e power j theta plus 2. So as epsilon tends to 0, this tends to 0, this also tends to 0. The only 1 by 0, this becomes 1, this becomes 2, 1 by 0. Therefore, 5 upon 0 e power j theta, or 5 by epsilon equal to infinity e power minus j theta. Theta varies from minus pi by 2. Theta varies from minus pi by 2 to plus pi by 2. Here, because of this minus sign, it is radius of infinity. The mapping is radius of infinity. Mapping is radius of infinity, and angle varies from plus pi by 2 to minus pi by 2. This is the Nyquist plot. This is the Nyquist plot. So, what is the Nyquist plot? Nyquist plot is this is for C1 segment C1 up to minus j infinity. This is for C3. This is up to plus j infinity. The mapping of C1. This is mapping of C1. Mapping of C1. This is mapping of C3. Mapping of C2 is a dot at C1. This is mapping of C2. Then this is mapping of this is mapping of C4. Its radius is infinity. It varies from pi by 2 to minus pi by 2. Its radius is infinity. Its radius is infinity. This is the mapping. So now we have to find where it intersects the real axis. To find that, let this point be A. To find the point A, that is intersection with the real axis, that we have to find. To find the point A where it intersects the real axis, we have to consider the transfer function g of j omega equal to 5 upon j omega plus 1, j omega plus 2. So multiply the complex conjugate on both sides, numerator and denominator. What you will get 5. Complex conjugate of this is 1 minus j omega, and for this 2 minus j omega. If you multiply this, this j will come here, minus j. If you bring this j numerator, you will get minus j omega multiplied by omega square plus 1, omega square plus 4. So this is from this we can write minus j5. What you will get minus omega square minus 3 j omega plus 2 plus 2. So what you will get upon omega square plus 1, omega square plus 4. If you bring equate imaginary part to 0 to get point of intersection with the real axis, because at this point imaginary part of omega equal to 0, imaginary part of g of j omega, imaginary part of g of j omega equal to 0. That's why we are taking the imaginary part out and we are equating this to 0, minus j5 and minus omega square plus 2 equal to 0. Or omega square equal to 2, or omega equal to plus or minus root 2, plus or minus root. So for this we have to find modulus of g of j omega. Modulus of g of j omega 5 divided by omega root 2, omega square root of omega square plus 1, 2 plus 1 square root of 2 plus 2. That is equal to 0.833. Therefore, the point of intersection A equal to point of intersection A equal to minus 0.833. A equal to minus 0.833. Therefore, the Nyquist plot doesn't encircle minus 1. Minus 1 is here. Minus 1 is here. It doesn't encircle minus 1. Therefore, n equal to 0. What is P? Consider this transfer function. Here n equal to 0, P equal to 0. Therefore, Z equal to P plus n. That is also 0. Therefore, the given system is stable for a gain of 5. The given system is stable for we have to write given system is stable for the gain, static gain 5. What is the range of K for stable? That is range of K for stable is, here it is 0.833. If we divide this by 5, because we have to take K equal to 1 to find the gain margin. So, but K equal to 5 here, that's why we have to divide this by 5. Therefore, A equal to 0.833 divided by 5. How much? 0.833 divided by 5. 0.16. Therefore, gain margin equal to 1 by modulus of A, that is equal to 1 by 0.16, equal to how much? 6.2. Therefore, we can increase a gain of 6.2. Already it is 5. If the value is above 6.2, definitely it will be unstable. Sketch the Nyquist plot for a system with open loop transfer function G of S H of S equal to K multiplied by 1 plus 0.4S multiplied by S plus 1 upon 1 plus 8S multiplied by S minus 1. Determine the range of K for which the system is stable. First of all, we have to get the Nyquist contour. This is the Nyquist contour on S plane. It goes from 0 plus to J infinity. That segment is called C1. The second segment is called C2. Its radius is R. R tends to infinity, and theta varies from pi by 2 to minus pi by 2. So it is a semicircle of radius infinity. It goes up to minus J infinity. That segment is called C. The next segment is called C3. It goes up to 0 minus. So it consists of 3 segments, C1, C2, C3. We have to do mapping of this 3 segments on G of S, H of S, so that we will get a plot on GH plane. That is GH plane. That is called, this axis is called, x-axis is called real part of GH, and y-axis is called imaginary part of GH. Now we have to do the mapping of C1. First, let us do the mapping of C1. To do the mapping of C1, consider what is the C1. What is the value of omega? It varies from 0 plus to infinity. What is G of J omega? GH of J omega equal to K multiplied by 1 plus 0.4 omega J 0.4 omega multiplied by 1 plus j omega upon 1 plus j 8 omega multiplied by minus 1 plus j omega. What is modulus of g h of j omega? That is equal to k square root of 1 plus 0.16 omega square root of 1 plus omega square upon 1 plus 64 omega square multiplied by 1 plus omega square. 1 plus omega square getting cancelled. Therefore, angle of gh of j omega equal to tan inverse of 0.4 omega plus tan inverse of omega. These two for numerator. For denominator, you will get minus tan inverse of 8 omega minus tan inverse of omega by minus 1. Real part is minus 1. Therefore, real part is minus 1. That's why this can be written as, this is in the second quadrant. That's why it can be written as minus of tan inverse 180 minus tan inverse of omega by 1. Now, when omega tends to 0, what you will get here is modulus of gh of j omega equal to k. Angle of gh of j omega equal to, this is 0, this is also 0, this is also 0, this is 180. Therefore, minus 180 degree. When omega tends to infinity, what you will get? Gh of j omega equal to, you will get infinity by infinity form. So, as a limiting case, you have to find the polynomial and you have to differentiate the numerator denominator with respect to omega. Finally, as a limiting case, you will get 0.05 k. Angle of gh of j omega equal to, for this you will get 90 plus 90, for this plus 90, minus 90, minus 90. Therefore, angle is 0. So if you tabulate all these values from omega equal to 0 to infinity, you will get this table. For intermediate values, if you find for 0.5, you are getting 0.24 angle minus 191. For 1, you are getting 0.13 angle minus 151. For 5, you are getting 0.0559 minus 47. For 10, you are getting 0.05 angle minus 24. These are all you are getting by substituting the magnitude of omega equal to 0.5, 1, 5, 10, and 100. These are the values you got. You notice that initially it goes above 180. That's why it goes above negative real axis and then come down negative real axis. That's why the approximate plot is looking like this. The approximate plot is looking like this. So the initial value is k 180, that is minus k. After that, angle increases. That's why it goes up. Then angle decreases. Finally, angle comes to 0, that is 0.05 k. Now, this is mapping of C1. Here, we have to find this point of intersection with the real axis. To find this point of intersection with the real axis, what we have to do is, we have to equate the imaginary part of gh of j omega equal to 0. That is, if you multiply the complex conjugate of denominator with numerator and denominator, you will get 1 plus 64 omega square, and multiplying the numerator and denominator by complex conjugate of denominator, 1 plus omega square, and numerator you are getting k multiplied by -1 minus 17.4 omega square plus 3.2 omega power 4 plus j 5.6 omega and minus j 14 omega cube. So these two are imaginary parts. These two are imaginary parts with k. Therefore, imaginary part of gh of j omega equal to 5.6 omega minus 14 omega cube multiplied. This is the imaginary part. We have to equate this to 0. Therefore, omega multiplied by 5.6 minus 14 omega square equal to 0, or omega equal to 0, 0.632. These are the two values we are getting. For this value, we have to find modulus of gh of j omega when omega equal to 0.632. That is, if we substitute on this modulus of g of j omega here, if we substitute here, what you will get is 0.2k. You are getting 0.2k. Therefore, the point of intersection with the real axis, this point is 0.2k. Now we have to do the mapping for C2, mapping of C2. Mapping of C2 is omega equal to r e power j theta. R tends to infinity, and theta varies from pi by 2 to minus pi by 2. For this, what is g? What is g of j omega, h of j omega equal to what you will get? Substitute r e power j theta omega. So k 1 plus j 0.4 omega equal to r e power j theta, and 1 plus j r e power j theta upon 1 plus 8j r e power j theta and 1 plus minus 1 plus j r e power j theta. If we take r e power j theta outside, g h of j omega equal to r square e power j 2 theta. You will get outside r square e power j 2 theta, and here you will get 1 plus j 0.4 divided by r e power j theta. 1 by r e power j theta plus j plus j. The denominator 1 by r e power j theta plus j8, 1 by r e power j theta plus j minus 1 by r e power j theta plus j. That's all. So r tends to infinity means these are all become 0. R tends to infinity means these are all become 0. Therefore, gh of j omega equal to this r e power j theta also getting cancelled. Therefore, finally you will get j 0.4 multiplied by j upon j8 multiplied by j. All j getting cancelled. Therefore, you are getting 0.4 divided by 8. In addition, you are having k. That is equal to 0.05k. So, the mapping of C2 is nothing but a point at 0.02k with that's all. Therefore, the mapping of C2 is a point at 0.05 K. That's all. Now we have to find the mapping of C3. That is omega varies from minus infinity to 0 minus. For that, it is a mirror image of mapping of mirror image of mapping of C1. That's why it is nothing but the mapping is mirror image of mapping of C1 means it will be like this. That's all. So it goes this way, then it stays here for omega equal to infinity, and then it returns like this. That's all. So now we have to discuss the stability of the system. So this is the mapping. There are three possibilities. One is the minus one may be here, or the minus one may be here, or the minus one may be here. There are three possibilities. When minus one will be here, the case one is minus one will be there if K is between 0 and 1. Case 1. In that case, if K is lies in between 0 and 1 means this point, this minus K will move between 0 to minus 1. In that case, for this range of K, the system is n equal to what? N equal to 0. No encirclement with minus 1. What is P in this case? In this case, P is one pole is on the right hand side. Therefore, number of poles on the right hand side, P equal to 1. One pole is on the right hand side. Therefore, P equal to 1, N equal to 0. Therefore, Z equal to P plus N, that is 1 plus 0 equal to 1. One closed loop pole is on right hand side, and the system is unstable. That's all. Case 2. That is second case. That is minus 1 is not here. It means K is greater than 1. K is greater than 1. K is greater than or equal to 1. And but this point is less than 1. Therefore, what is that point? Greater than 1. 0.2 K equal to 1 means K equal to 1 by 0.2 equal to 5. But K is greater than 1 but less than 5. In that case, minus 1 is lies in between minus K and minus 0.2 K. Minus 1 will be lies in between minus K and 0.2 K. In that case, N equal to what? N equal to 1 plus 1, because it is in the clockwise direction. And P equal to what? P also equal to 1. Therefore, Z equal to P plus N equal to 1 plus 1 equal to 2. Therefore, 2 closed loop poles on the RHS and system is unstable. Then case 3. Case 3, what it says, if case 3 is, if minus 1 is here means 0.2 K is greater than 1. 0.2 K is greater than 1. that is k is greater than 1 by 0.2, that is equal to 5. Case 3 is -1 is between 0.2k and origin. So it means the k should be greater than 5, greater than or equal to 5, and less than infinity. In that case, it is the encirclement is in the anti-clockwise direction. Therefore, n equal to -1, but p equal to 1. Therefore, z equal to n plus p, that is equal to -1 plus 1 equal to 0. Therefore, the system is stable for this range of k. That's all. That's all about this. Relative stability using Nyquist criterion and M circles. M and constant M and N circles. This is Nyquist plot. This is Nyquist plot of third order type 1 system. We know. By using this, we can find the relative stability. Relative stability means we have to find the gain margin and the phase margin. To find the gain margin, we have to find where it intersects negative real axis. Say A. If it intersects at A, if it intersects real axis before -1, then it doesn't encircle -1. -1 plus J0. This is the point, -1 plus J0. It doesn't encircle. That's why the given system is stable. That we can tell. What is the relative stability? For that, we need the gain margin and phase margin. Gain margin equal to 1 upon modulus of A. 1 upon modulus of A is the gain margin in linear scale. Suppose you want gain margin in decibel scale, we have to find 20 log 1 upon modulus of A, or -20 log A, modulus of A. That is gain margin in decibel scale, in dB. What is the meaning? If you suppose here gain is 0.5 means, what is the gain margin? Gain margin equal to 1 by 0.5, that is equal to 2. So, we can increase the gain by 2 so that the system will be in the verge of instability. That is gain margin. We can increase the gain by 2 so that the system will be in the verge of instability. That is gain margin. So, 1 by modulus of A in linear scale. If you want tell in decibel scale, we have to take 20 log 1 by modulus of A. Suppose this plot goes like this. Here it intersects A1. Here the system is unstable because it encircles -1. Since P equal to 0, it encircles -1. Therefore, here, what is the gain margin? The gain margin will be less than 1 because it is A is greater than 1. Say 2. 3. Let us assume that it intersects at -3. Therefore, gain margin equal to 1 by 3 modulus of A. That is 3. That is 0.33. It means if you reduce the gain by 0.33, the system will be in the verge of instability. So already the gain is greater than K max. If you reduce the gain by 0.33, by the factor 0.33, then the system becomes the verge of instability. If you further decrease, the system becomes stable. That is the meaning. But if gain margin is less than 1, linear scale. If gain margin is less than 1, unstable. Unstable. If gain margin is greater than 1, stable system. If it is gain margin equal to 1, marginally stable. Marginally stable. These are all in linear scale. Linear scale. What is phase margin? Phase margin. From Nyquist plot. What is the phase margin in Nyquist plot? Phase margin equal to, draw a unit circle. This is unit circle. -1, +1, plus j, minus j. The Nyquist plot cuts the unit circle at A. The angle at that point is phi. Suppose say this is 135 degree, minus 135 degree. Therefore, phase margin equal to 180 minus 180 plus phi. That is equal to 180 minus 135, 45. Therefore, the phase margin is 45. The meaning is, if you increase the phase angle further from minus 135 to minus 180, the system becomes the verge of instability. That is phase margin. So if you increase the gain, if you increase the phase further by minus 45 degree, then system will be in the verge of instability. That is the meaning of phase margin. That is the meaning of phase margin. So without adjusting the gain, we can make the system in the verge of instability by increasing the phase alone. Constant M circles. Constant M circles. We know, suppose closed loop transfer function T of S equal to G of S, unity feedback system. Unity feedback system. G of S upon 1 plus G of S. What is T of J omega? Equal to G of J omega upon 1 plus G of J omega. But if you find the G of J omega, it is a complex number. It is a complex number. If you substitute any point in that, you will get a complex number. You will get a complex number. So it is a complex number. So we can say that the G of J omega can be Jx plus Jy. We can call G of J omega as x plus Jy. Therefore, this closed loop transfer function becomes x plus Jy, because G of J omega is a complex number. 1 plus x plus Jy. What is modulus of this can? What is modulus of T of J omega? That is equal to modulus of x plus Jy upon modulus of 1 plus x plus Jy. Let us call this as the modulus value as M. What is phase? Phase of T of J omega equal to angle of x plus Jy upon 1 plus x plus Jy. That let us call it as e power j theta. Therefore, magnitude is M, angle is e power j theta. Or we can call this as T of J omega may be called as magnitude with angle. E power j theta, m e power j theta. M is magnitude. What is m square? M square equal to m equal to what? Square root of x square plus y square. So m square means x square plus y square upon 1 plus real part square plus imaginary part square. We will put square root. If it is m means we'll put square root. That's all. Real part square plus imaginary part square. Therefore, m equal to x square plus y square upon 1 plus x square plus y square. If you cross multiply this, what you will get? 1 plus x square is 1 plus 2x plus x square multiplied by m square plus y square m square equal to x square plus y square. This can also be written as what we got, m square multiplied by 1 plus 2x plus x square plus m square y square equal to x square plus y square. Except m square, bring all to the right hand side. Let us write one more step. M square plus 2x m square plus x square m square plus m square y square equal to x square plus y square. Keep m square in one side and all other things bring to the another side. You will get m square equal to x square plus y square plus x square plus y square plus minus 2x m square minus x square m square minus m square y square. Group x square together. X square together 1 minus m square. Similarly, bring y square together 1 minus m square y square. Then what is the remaining things? This is taken. This is also taken. The only thing is minus 2x m square. Divide on both sides by 1 minus m square. You will get m square upon 1 minus m square equal to x square plus y square minus 2x m square upon 1 minus m square. So some x square y square is there. That's why this equation can be shown as circle. So if you add on both sides, deliberately add on both sides, m square minus 1 minus m square whole square plus m square divided by 1 minus m square. I am deliberately adding m square upon 1 minus m square whole square on both sides. You will get x square plus y square minus 2x m square upon 1 minus m square plus m square upon 1 minus m square whole square. So if you consider this and this together, what you will get is, yes, if you consider this and this together, you will get x minus m square upon 1 minus m square whole square. You will get x square, you will get this square minus 2x m square divided by 1 minus m square. You will get plus y plus 0 whole square equal to You have to simplify this so that 1 minus m square whole square. So you have to multiply this this with 1 minus m square. 1 minus m square plus m power 4. That is equal to m square minus m power 4 plus m power 4 upon 1 minus m square whole square. These two getting cancelled. Therefore, the right hand side is m square divided by 1 minus m square whole square. So, this is an equation of circle. This is an equation of circle. This is an equation of circle. What is center? Center is this is x minus yes, sorry, the center minus. So the center is m square upon 1 minus m square, and 0 is the center. Radius equal to square root of this, that is m divided by 1 minus m square. So it is a circle of radius m upon 1 minus m square. And the center is at m square upon 1 minus m square, comma 0. So it is a circle. What is m? M is magnitude of closed loop transfer function. How we can vary magnitude? By varying k. If you vary k, automatically m will vary. You will get circles of radius m upon 1 minus m square. M upon 1 minus m square, and center is at m square upon 1 minus m square, comma 0. This is a circle. If m varies, you will get different circles. This is called m circles. If you vary m, you will get different circles. But this equation will fail when m equal to 1. When m equal to 1, what will happen? When m equal to 1, 1 upon 1 minus 1, this becomes 0. Therefore, infinity, and radius also infinity. That is not possible. This equation fails when m equal to 1. Therefore, we have to consider this equation, when m equal to 1. If you m equal to 1, what you will get? X square plus y square equal to 1 plus x square. This side it will come m equal to 1. M equal to 1 square, m, that is 1 square, multiplied by the denominator will come there. That is 1 plus x square plus 2x plus y square. Therefore, x square getting cancelled, y square also getting cancelled. Therefore, the remaining thing is 0 equal to 1 plus 2x, or x equal to minus 1 by 2. It is equation of straight line. So when m equal to 1, it is straight line. Otherwise, it is a circle. When m is greater than 1, you will get set of circles. When m is greater than 1, you will get set of circles like this. When m is less than 1, you will get set of circles like this. When m equal to 1, you will get when m equal to 1, you will get a straight line at x equal to minus 1 by 2. X equal to here at this point, x equal to minus 1 by 2. So it is a straight line. Otherwise, it is a circle. So what will happen if m is greater than 1, m tends to infinity, what will happen? Center is m square. Center is m square divided by 1 minus m square. As m tends to infinity, you will get infinity by infinity, infinity by infinity. So if you differentiate the numerator and denominator once, you will get 2m divided by minus 2m. Again infinity by infinity. Again infinity by infinity. If you differentiate one more time, what you will get 2 by minus 2, that is minus 1. So the center goes to when m tends to infinity, center becomes minus 1 comma 0, and the radius tends to 0 because here denominator degree is higher. That's why it will goes to infinity, and 1 by infinity becomes 0. So radius tends to 0. That is mentioned here. The center is finally, as m tends to infinity, center goes to minus 1 comma 0. 0. On the other side, what happens? The center is m square upon 1 minus m square comma 0. Radius is m upon 1 minus m square. As m tends to 0, here the maximum value is just below 1. The minimum value is 0. As m tends to 0, what you will get? 0 upon 1. Therefore, 0 comma 0. Finally, as m tends to 0, the center goes to 0 comma 0. That is here. The center goes to 0 comma 0, and radius also goes to 0. As m tends to 0, radius also tends to 0. That is mentioned here. So these are all called set of m circles.